And all right, good morning. Let me get this room number down here. 227, 217. All right, I cannot join with my other computer for some reason, but here comes another student. Hey, good morning, good morning. Here we go, screen share, this one. All right, so I got 21 questions. I've got to add Grace's name to my wheel picker. And let's see. Okay, here we go. First one up to pick. First one up to pick is going to be the lucky first winner is Peyton Buchanan. All right, Peyton, pick a number from 1 to 21. She picked 21. Okay, all right, let's see. Oh, it's math. All right. And it's not even multiple choice. She gave you guys a tough one. Okay, let's see. I'm going to give you a few seconds to read this. Get some paper and a calculator handy. Man. Let's see. Oh, I lost somebody. All right, I got my calculator out in case we need one. All right, you guys ready? Anybody got some equations for me? Let's see what's in the chat. Okay. All right. Just gonna type back some things to kids. Yeah, put my glasses on, man. Oh, it's tough. I'm gonna turn my video off for a second. All right, thanks for chatting me those responses. If I didn't chat you anything, then your response was probably pretty good. So I'm going to start here with the initial question, which was that it's 30 minutes on the first day and an extra 2 minutes per day after that. So a couple of small points that may happen for you guys. You got to remember that they're asking you to use the language of T of D. So technically, this has to be the beginning of your sentence. So the time per day is equal to what formula? That's what they're asking for. So it's 30 minutes on day 1. And then every day after that, you have an additional 2 minutes, right? So it's 30 minutes on day 1 plus an additional 2 minutes per day, 2 minutes per day, as long as D is greater than 1, because on the first day it's 30. So your equation had to look exactly like this. If you have this, you would lose a point because they specifically stated that they wanted it in function notation. So just note to self, okay? You don't want to lose points for things you understand. So for 6 minutes, it would be 30 minutes the first day, plus 6 days worth of additional 2 minutes. And that would give us 30 plus 12. This is a tricky question. This is a tricky question. Because I think some of you didn't realize that the first day was actually day 0, and that was 30 minutes. He didn't do an additional time. Then after that, on this additional day, it would be 32 minutes, etc., etc. Does that make sense what I'm saying? Hopefully you're seeing what's going on here. Because a couple kids said 40, so it's actually 42 minutes. 42 minutes. All right, I'm gonna leave that up here for a second for anybody that's writing things down. Welcome. All right, now back to the game board. Back to the game board. All right, here we go. We gotta pick a new student to choose. So the next winner is Grace. Grace, you're up. Chat me a number or unmute. Five. Oh, I got to cover up 21 was chosen. And now number 5. All right, we got a multiple choice here, kids. Let's see how you do. I'll give you a couple seconds to work. All right, so I got some numbers coming into the chat. If you chatted me an answer, I probably responded to you. All right, so I got 1, 2, 3, 4 answers so far. Anyone else want to offer a response? Sorry, I keep leaning over here to try and join on this other on this other computer. 1, 4, 4. All right. Okay, I'm going to post up an answer now. Here's a couple of ways you could solve this. One is you could type it in your y equals button, right? You could certainly do that and take a look at the zeros. I'm going to quickly do that. 3x squared minus 3x minus 6. So in my y equals button, I'm going to clear this out. I have 3x squared. Sorry. Minus 3x minus 6. Okay, minus 3x minus 6. Take a quick look at my graph and I can see very quickly there are the zeros, root solutions at -1 and +2. This is a multiple choice question. So time is of the essence, right? If it's a multiple choice and you don't have to show work and you know how to use your calculator, you should use your calculator. So choice number 4 was the right answer. If this question had no choices and you had to show your work on your own, You could solve this by using the quadratic formula for sure. You could also solve by factoring. I see here that these all are multiples of 3, so I could have pulled out that GCF here. And when they're looking for zeros, remember they're asking you to take away the f of x and put the equals 0 sign. If I divide everybody on this side and that side by 0, I don't actually have to GCF. This is a division property of equality, and that's different. It's causing all of these numbers to change. I would get x squared minus 1x minus 2 equals 0. In which case I could then factor this polynomial here. My board is not working. Oh, I switched the side, sorry. I'm like, where is that thing? So I'm looking for something that multiplies to -2, but adds to -1, and that's -2 and +1. These are the factors, and remember factors are always the opposites, right? The opposites of your solutions. All right, great job. Back to the game board, back to my spinner. Thank you, Grace. And this time, the lucky winner is Peyton Elliott. All right, kiddo, chat me a number. She's going with
14.
Lucky number 14. All right, here we go, man. Okay. I'll give you time to take it in. All right, kids, chat me some equations. Let's see what you've got. Here's a hint in case you're stuck. If you have a constant daily rate, a constant rate of change, you are linear. You are linear. All right, good job. I'm typing some different things to different people, so that's why I'm being quiet right now. So there's 2 ways you can do this. You can do it yourself by figuring out the initial value, or when y is 0, and figuring out the rate of change. You can figure those out yourself, or you can put this in your graphing calculator and compute the linear regression. All right, I'm leaning in. I gotta turn my camera off. I look ridiculous leaning in trying to read these things. Okay, thank you. Yeah. Can you hear that? Can you hear that? My Alexa reminding my daughter for violin lessons. Okay. All right, so I'm going to start answering this one here. First, I will do it by the actual algebra, the actual math that you would use. So if we have a constant daily rate, then we have a linear function. The initial value is when the x, or in this case, the n, is 0. And we don't see that in the chart. We do see that we have a constant pattern here, that from day to day, it is increasing at 1.5. So if I needed to find the 0 value, I could reverse my pattern, right? Okay, I got some better answers coming in. Almost, not quite. Let me just chat that right here. All right, so if I work this pattern backwards one time, I would be subtracting 1.5, and that would give me the actual same number, 1.5, right? So my initial value here is 1.5. And my rate of change, which is my pattern here, is also 1.5. All right, so they're asking you to write an equation to represent h of n. So I can't use the letter y, I have to use the letter h of n. And I literally have to use the letter n. So you see when I have y equals mx plus b here, I have to go in and modify it. So technically it's h of n equals 1.5n plus 1.5 plus 1.5. So a couple of you chatted me there. Some of you got it right. Some of you missed it by a bit. If you used your calculator, you would have went into your stat edit button. You would have typed a 1, 2, 3, 4, 5, I think it went up to. You don't even have to type them all. And yes, we would start at 3.0, 4.5, 6.0, 7.5, and 9.0. And then from there, I would stat, calc, lin, reg, enter, 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 and voila. See, you can use your calculator. You didn't even have to hurt your brain to get through this. So that's another way you could have solved this. All right. And all it asks you to do here is to write the equation. So that's all that you needed to do. They were looking to make sure kids started like this, h of n. All right. Thank you very much. Question 14, back to the game board. 14 is taken. And back to my spinner. Next up. Okay, who's picking this time? It's Carolina. Woo! What's your lucky number, kiddo? 18. All right, let's see what we got. Oh, we got a fun one. 3 things for you to look for. Who can find one? You're looking for a flashlight. You're looking for a slice of pie. And you're looking for a glove. Although that glove is pretty creepy looking. All right, chat me if you think you found one. Ooh. I don't want to give any away, so I'm chatting to people when they get it right. Can you find all 3? All right, a lot of kids found, oh, there we go. Oh, yes. Yep, good job, good job. All right, I'm not going to chat anymore. A lot of you kids are finding them. I think the most popular one that was found was this one here, the glove. That was the most popular one that I got a lot of right responses for first. So if you haven't found it, take a quick look. I think the hardest one, I think only 2 or 3 kids found the slice of pie. So the glove was over here. The glove was over here. The flashlight was in the kid's pants. And then the slice of pie was right up here on the roof, right up here on the eave of the roof, right up there. All right, kids, thanks for playing. Thanks for playing. All right, that was number 18. And back to the wheel picker. Here we go. Next up is Stone. Stone, pick a number. Actually, I think Stone left. Stone left. All right, I'm spinning again. Deanna, you're up. Pick a lucky number. Lucky number 3. Here we go, kids. Oh, all right. We gotta do some math. Get those calculators out. Okay, got some answers coming in. All right, most of you guys got it right. So I just chatted. So the kids that need to keep thinking, but for the rest of you, I would put this in my calculator. I mean, you can do it yourself, but why not? Why not put that thing in your calculator? Square root of 2x plus 3. So I would go back to my main screen. I would get a big fraction bar going. I would get my square root sign going. I would get 2 parentheses. Look, I can even put a fraction in this fraction. Dang, this calculator is fancy. Look at that. Close it. And then I think it was plus 3. All right, plus 3. And then down in the denominator, the 6x minus 5. So I put 6. I'm wasting all my time with this 1/2 fraction business. I should have just put 0.5. That would have been so much faster. Anyways, plus 5, right? Oh, minus 5, minus 5. What? Don't want to get it wrong now. -1. Yes, all of you who chatted me a 3. Whoop, whoop. Okay, and maybe some of you did it in your head, which is fine. If you had to show work, you would have just had to show this on your paper. That's all you would have had to show on your paper. And you literally could have done the rest in the calculator. All right, thanks for picking number 3. Next up on my picker wheel, let's see. Gabby, you're up. Pick a number, kiddo, pick a number.
17.
17, all right, girl, you sound asleep. Let's go. Okay. Whoo. All right, I'm gonna let you guys think about this one. All right. Well, there's only one right answer, but I guess I'm really interested in how are you justifying your answer? Okay, I see some good. I did not chatting back because I was trying to do something on my other computer here, but that's a good justification. Let me just chat. Some kids. All right, so let's do the algebra answer first, and then I'll talk about other kids that chatted me responses that are also correct. In order to know how many solutions something has, you have to understand this number, right? You have to understand the discriminant, because the discriminant really does determine how many solutions you have. The discriminant is that value underneath the square root sign. So the b squared minus 4ac, that's the square root sign. Yep, the thing under the radical is called the discriminant. And without the square root sign, this is your formula, right? So it is the piece under the square root sign, but we don't even need to focus on the square root sign right now, because when you square root a negative number, it's not possible. So if you have a negative number, you know you have no solutions. If you have a perfect zero number, you have one solution or a double solution. And if you have any random positive number, you have two solutions. So this is the algebraic way to justify your answer. But there's more than one correct answer here. But this is the algebraic way to justify your answer. So b squared minus 4ac would give us negative 2 squared minus 4 times 1 times 5. Which would give us 4 minus 20, which would give us negative 16, which is negative. So therefore, there are no solutions because the discriminant is negative. All right, so that's one justification. It's pretty fancy, but it is something you were taught, and I wanted to revisit it with you. It's not the only right answer, but technically this would be that sweet spot, right? This would be the answer that we would love to see. But if you also were to look at this because you're like, how many solutions does it have? Let me plug that in my calculator, and you go to your y equals button and you type in x squared minus 2x plus 5, x squared minus 2x plus 5, yep. And you take a look at the graph, then you could kind of sketch something like that. You could sketch that on your paper, right, with your 1, 2, 3, 4, 5, and you kind of sketch like that. And you could write this same sentence that a lot of kids chatted me in the chat. There are no solutions because the function, the parabola, whatever the equation, so the function does not cross the x-axis, right? So that is a justification. So this is a 2-point question. You get 1 point for saying there are none. You get 1 point for saying that, and then you get another point for one of your justifications, whether it's math-based, using the discriminant, or whether it is graph-based, stating that you know that it doesn't cross the x-axis. So thank you for picking number 17. And let's get to our last 3 lucky contestants who haven't gotten to pick yet. And let's see, Indiana, you are up, girl. Hey, what's your lucky number choice? She is going with number 2. Oh, okay, multiple choice. Multiple choice it is. Little vocab review. Which representations are functions? All right, got some answers coming in. Everyone who has chatted me so far is correct. Good job. Hopefully you remember what you're looking for. Awesome. Let's see. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5. All right. I'm still waiting on 4 kids, but hopefully you know that a function has no repeating x values and it passes the vertical line test. Has no repeating x values and passes the vertical line test. So I'm looking here at choice Roman numeral 1, and I've got some repeating x values. So that is not a function. So anything with a 1 in it, I can rule it out. Now I'm going over here to 2 and I'm doing my vertical line test and it fails the vertical line test. So that is not a function. So anything with a 2 in it is out. So I've either got to go with 3 or 4. 1, 2, 3, 4, 5, 6, 7. Got no repeats. What is the question? Which representations are functions?
You
Oh,
miscrossed something.
I crossed it off. It's a 3. Sorry, thank you. This is function 3. This is function 3. This one is function 3. Thank you. All right, so 2 is a function, and number 4 is a linear function, y equals 2x plus 1. So that would go through 1. It would go up 2 over 1. That's a linear function, and that would pass the vertical line test. So yes, it's choice number 2. Choice number 2. Thank you, thank you. Next time, be more careful than me and don't cross off the wrong value. Game board. All right. How many kids are left? Just 2, Christian and Kevin. Who's going to be the cheese that stands alone? Oh no, this feels bad. Oh, Kevin, you're the winner. You're the winner. You're the winner. Oh, Christian, that's okay. We're going to reset the wheel anyway. So, Kev, what do you pick? What do you pick? He picks number 9. Lucky number 9. Ooh, I'm glad this one came up because I want to talk about it. All right, I got 2 sets of data below that represent the number of runs scored by 2 different youth baseball teams. All right, so I'm curious if you understand how to find the mean and how to find the standard deviation. And you should be using a calculator. You should be using a calculator. Okay. You could find the mean yourself by adding up all of these digits and dividing by how many you have. You could certainly do that and then start eliminating. All right, you could certainly do that. Or you can open your calculator here. I'm going to shrink mine down, sorry. You can open your calculator and you could use the stat button. And you can edit that data in one list only. So I'm going to do team 1 in list, team A, sorry, in list 1. They have 4, 8, 5, 12, 3, 9, 5, 2. And I'm going to put team B in list 2, 5, 9, 11, 4, 6, 11, 2, and 7. All right. So when I press stat and I go over to calc, I'm going to choose one variable statistics and I have to tell it where my list is. So if this right here, if this feature right here, hopefully you can see it there, it says L1. So that's team A. So if I keep that as L1, I can find the mean, which I'm not sure if you guys know, is this one right here. The X with the bar over it. Okay, the X with the bar over it is your mean. That's your mean. Okay. So the X with the bar over it is 6. So I'm going to say that the mean for team A is 6. And now I can either do it myself or I can use my calculator to do list 2. So if I go back to stat, calc, and I want to change this from L1 to L2, I clear this out and press L2, which is right here in blue above the number 2. So alpha L2. And then I enter a couple times. And look, that mean is 6.875. 6.875. So already I can start eliminating things just by using this simple calculation of mean. So A is lower than B. So that means choices 2 and 4 are out. Okay. Now, standard deviation tells you how far apart these scatter points are from your regression line. Okay, so how far apart they are from your regression line, right? That correlation coefficient also is like a little like bell kind of curve like this. So if all of my data is kind of like this, right? I have a little bit over this way, I have a little bit over that way. How far it goes is the standard deviation. Oh, like you guys don't even care about that business. Let me just show you the important part. When you are running your stats, right here, the sigma x, that's your standard deviation. So the standard deviation for the second function is 3.05. 3.05. Okay, so I'm going to go back here. I'm going to take some notes. The standard deviation for this one is 3.05. Now I've got to go back into my stat, calc, and I've got to change this back to L1 so I can do my standard deviation from L1, which for us is 3.16, right? You see it right here? 3.16. So this one is 3.16. So team A has a larger spread, right? A larger spread of data. The standard deviation of 3.16. So I know that team A is less than, but its standard deviation is greater than. So maybe now that I showed you how you can find that standard deviation, you can answer those questions moving forward. Okay, yep. Question 1. All right, this was 9. We are back to our main board. I don't even need to spin my spinner because we know Christian is the next student to pick. But I like to see the celebration. All right. Christian, what's your number? He is going to pick 7. 7. That was a long wait. That's right. All right, Christian. Thanks for picking 7. We appreciate your patience. All right, kids, give this a go. You should be using your calculator for this. That would be a fast way to do it. Especially since it's a multiple choice question. All right, let's take a look at some answers. Okay, I got one answer in the chat. Yes. Ooh, that's weird. All right, I got two answers in the chat. Fantastic. If you're stuck, I would have typed these two into my graphing calculator like this, and I would have looked at my table to kind of see here, right? So if I go back to the question, I can't see with these decimals though, right? But I can definitely rule out if X is equal to at 4. So I'm going to take a look here. And yes, at 4 they are. Oops, sorry, wrong thing. So I know that they are definitely equal to each other when X is 4. So I can definitely say that one of these has got to be the right answer. So I can now go and check this value mathematically, or I can check the 0 value, right? So I go back to my calculator and I arrow up. If X is 0, are they equal to each other? No, they are not equal to each other. So I can definitely say that this is wrong. So by default, this one must be right. And if I want to prove it, I would replace this X with a negative 1.75, and I would replace this X with a negative 1.75. Or I could even do this. Watch, I could even go to my calculator and I can go over here. I'm not sure if you can see what I'm doing, so let me circle it. And go over here to that blue word that says table set. Table set. I'm going to press second table set, and guess what I'm going to do? I'm going to make this a negative 1.75. I'm going to start the table at negative 1.75. And now look, boom. There it is. I can see that they're equal. Now, my chart is going to go by ones from there. So that's a little bit crazy, but it is a shortcut. It is a shortcut. So I am going to correct my calculator now, though, because when I change the table and then I don't change it back, it screws me up later, and I hate that. So I'm going to start my table back at 0. And now my table is going to go by ones again. All right, just a little fast fact for you on how to use that calculator. So yes, the answer was 2, and we just proved that. All right, we're going to start all over again. I'm going to spin my spinner. Oh no, what I gotta look back at my chat. What number was that? 7. That was lucky number 7. Lucky number 7 is gone. All right, kids, let's see. What else have we got? Back to the spinner, starting from the beginning. Okay, wake up, wake up, wake up. It's like it's going in order again. Oh no, I don't know. I hope it doesn't do that. Well, Peyton, you're up, kiddo. Pick a number. I hope it doesn't go that same order. Christian will be waiting all dang day. If it does, I'm gonna retype the names. Peyton Buchanan, you still here, girl? Chat me a number. Any number that you see. Okay, 6. 6 it is. All right, here we go. Oh, it's a good one. I'm glad you guys got this one. These are one of those tough ones. You don't want to practice things you do know. You want to practice things you don't know. Are you guys like, are you guys stuck? Got some answers coming in. Okay. Here's a reminder for you. A recursive function requires you to find the answers in a row. So like if I want to know the 10th number in the sequence, I have to know the 9th and the 8th and the 7th and the 6th and the 5th and the 4th and the 3rd. Okay. So what we're looking for it to happen is we are looking for it to have a first term that's equal to 10. A first term that's equal to 10. So hopefully you understand what that means. If your first term is equal to 10, then you can cross off 2 answers already. Okay, if your first term, that's the function's answer for the first position, right? If the first term is equal to 10, then you should be crossing off these choices. Hopefully that makes sense to you. Very good. Okay, so we've crossed off 2 and 4. All right, now we're starting to think, this is a phrase right here. Anytime you are subtracting 1 from your x value, that means you're doing the previous number. Okay, the previous number has a common difference of 4. Common difference of 4. So a difference is an adding or subtracting number. So a difference is an adding or subtracting number. Very good. I'm seeing some more correct answers come into me now. Thank you. Thank you. So a common difference is when you are adding or subtracting. Very good. So the answer for us, since 2 and 4 were eliminated using our common sense, is that we're not going to times each number by 4. We're going to have a common difference of 4. So that's adding a value of 4. If I said it had a common difference of -4, then it would have a minus sign here. But a common difference of +4 means that it is a plusing 4 pattern. Plusing 4 pattern. So yes, you are right. The answer is 1. The answer is 1. Very good, very good. Hopefully now this is coming back to you about f of 1. I know, don't doubt yourself. You've got this. All right, thank you for choosing 6. Let's see. I think it's going to say more. Carolina, you're up. I'm gonna change it after this, don't worry. She's like, I quit. All right, number 1, here we go. Which expressions are equivalent to 4x squared minus 4x minus 120? Well, you guys go do that. I'm gonna fix my spinner. One, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. All right. Peyton picked. Oh, Carolina already picked. Who am I missing? Christian, Deanna, Grace, and Deanna. Oh, I lost Gabby. Okay. All right, I fixed my spinner. Got a couple answers coming in here. Thank you, kids who chatted me. Oh, all right. Yes, yes, yes. Everybody who chatted me is correct. Thank you. I got 3 kids who chatted me, so I'm still waiting on a couple more. Looks like all of your choices here are some sort of like factored form of it. Some sort of factored form. So let's see, if we pulled out a 2, would we get this, right? That's what we're asking ourselves. If we factored out a 2, then this would be 2, this would be 2, and this would be 60. Okay, so this is a match. This is a match. Now this one says, what if you factor out a 4? So factor out a 4, we'd get 1, 1, and 30. Oh, this one's also a match. So I know 1 and 2 are definitely equal. So I can start crossing off some things because this is missing a 1. This is missing a 1. Does that make sense? How I'm kind of like, you know, working my way through this problem. I'm kind of working my way through this problem a little bit at a time. I tried the 2 easier ones, right? I tried the 2 easier ones. So now all I have to do is see if 3 or 4 works. See how this says 1 and 2 only? And this says 1, 2, and 4. So I don't have to check everything. I really just have to check 4 because those are my only options. Either 4 works or it doesn't work. So let's see here. Does this one work? Well, it looks like it's separating out this front piece. So if I'm separating out this front piece and I factor out a 4 and an X, if I factor out a 4 and an X, would this be the remainder? And the answer is yes. If I factor out a 4X, I would be left with just an X and just a 1 here. So 4 works. So the answer is 3. Congratulations to those of you that chatted me. The answer is 3. But sometimes when you have a multiple choice question, okay, and you know you got a lot of work to do, start thinking strategically by looking at these choices, right? Especially if it's something you feel like you can do quickly. So if you can figure out that 1 and 2 work quickly, you can start eliminating half of your choices, taking some of your anxiety and bringing it down a bit. All right, thank you for picking number 1. I did adjust the order of the names in my wheel picker. So those of you that are left, hopefully you'll be picked in a different order. Oh, Indiana, you're up. I feel like that happened last time, but that's okay. I won't say anything. I'm pretty sure that was the order last time. She's picking lucky number 8. Lucky number 8 is a fun question. What is that? OMG. What is that? What is that? That's crazy, huh? All right, so I have to read you some of these things in the chat. Some people are saying apple pie, rocks, a fish, a plantain, some sand, a cave wall, a cookie, a banana, a piece of wood, chicken. Ew, that's a nasty looking chicken. Or maybe it's like the fried chicken part. Okay. For a second there, I was looking down here and I thought maybe it was like from a pineapple, you know, like how that pineapple can kind of be like that. But it's not. It's none of those things I said. I don't even know if you're familiar with it. I don't know. I just took this off the internet. But here you go. You guys ready for the solution? It's nothing that you guessed. It's something totally different. It is a piece of cork. It's a piece of cork, like from a champagne bottle. I would have never guessed that. I saw that and I was like, oh, I would never guess that. So they zoomed in right here. They zoomed in right here. How cool is that? All right. Thanks for playing. Sorry, you got it wrong. All right. Number 8. Number 8 is gone. All right. We only got a couple more. We only got a couple more. Stay with me. Who wants to pick? Who wants to pick? We have a couple kids left. Next up, Kev, you're the winner. You're the winner, my friend. You are okay, Peyton. I hear you. Who wants to play? Who wants to play? 15. Sorry, Christian. Kevin says he goes before you again. He's picking number 15. Let's see. Is this another fun one? Oh, this is another fun one. What is that? First of all, that's gross. What is that? What is that? Kevin thinks it's mushrooms. Ooh, or jellyfish. Okay, okay. Peyton thinks it's mushroom. Deanna's like, bro, I don't know. Oh, maybe something under the ocean, like coral reef, or like this is like some type of octopi, octopus, a plant, some mushrooms. I'll tell you this, it is something you eat. It is well, I don't know if you eat this part of it, but it's part of something you eat. It's part of something basic. Mentos. No, but those sound delicious. I could go for some Mentos right now, at least the fruity kind. Yeah, I could use some sugar. Kimchi. Oh, okay. You eat kimchi. I don't eat kimchi. All right, you guys ready? 3, 2, 1. It's the seeds of a pepper. I know you guys eat peppers. I know you eat some peppers. Do you eat them raw or do you only like them cooked? That's the question. Some people can't eat them raw. I like them both ways. All right, thanks for picking number 15. Thank you, thank you. All right, who wants to select a question for me? Help. Peyton left. I should have taken her name off. All right, I'm gonna feel terrible if Christian is last again. I'm gonna feel terrible. Oh no! Tiana, you're up. Oh my gosh, poor Christian.
Am I allowed to give my turn to Christian?
Oh, Christian, do you want her turn? That's so kind. That's so kind of you. What'd you say? You gonna pick a number, Christian? Oh, he said, it's so fine. It's fine. He said, it's fine. I'm just going to sit here and martyr and be last. All right, D, you're up. Pick a number.
10.
10. All right, kids. Christian, Kevin says you should have taken it. Don't look a gift horse in the mouth. Just take it. All right. Thanks, Deanna. We're on to some math now. We only got a couple more to do. All right. If Lila completes the square, what would be the number in the A position? Careful, kids, careful. This is a tricky question, so look at it carefully. Okay. So completing the square means you're focusing here on the ax squared plus bx value, right? And when you complete the square, you give that constant a little shove over to the side, and then you even Steven by adding half of b squared, right? You even Steven by half of b squared. So for us, we'd be adding a 36 there. But then when we go to factor this trinomial, here, right? This 3-piece part and then the 36 plus 7 part over here. Remember, when you're factoring, you do the square root of the first and the square root of the last, and you keep the sign from the middle. Now look at this example here. There's already a minus sign here. So they're asking you just for the letter A. So when you complete the square and you're finding this answer in the A position, it's either the square root of the number you added, or it's just half of the B number, right? So even if I did none of this work, I know that half of this number is what always goes here. Half of the B number is what always goes there. So the answer for this one is 1. because 6 is half of that number. 6 is half of that number. So the number would be 1, okay? All right, catching you all up there. Hopefully you understand how we completed the square and why we got a 6. All right, thanks Deanna for picking number 10. It's between Christian and Grace. Oh no. Oh wow, Christian, you are not last. You are not last. Woohoo! All right, kiddo. All right, pick a number. What's left? We've got 4, we've got 11, 12, 13, 16, 19, 20. What do you pick, kiddo? He's going with lucky number 4. Lucky number 4. Ooh, it's a fun one. Can you find 3 differences in this photo? Name them for me. Name them for me. Oh, I didn't realize I had the chat on me only. Sorry. Next time I'll turn the chat to everyone. All right. Okay, we got some answers now. Thanks for playing. Oh, yep. Deanna found a couple. Kevin found them all. Christian found one. Yep, Deanna found them all. Let's go. All right. Oops, sorry. I didn't need to do that. Grace, can you see the picture? Do you see anything different? You didn't chat me anything. We got the
I
spoon.
don't see anything.
What? Look at this. The spoon forks are different. Look at the tasty pancakes. Come on. You know you wish you were eating pancakes right now. I wish I was eating pancakes right now. Yes.
Butter.
Butter. There's one more. Come on, girl.
The stripe.
Yeah, this like stripe on the shirt. Woohoo! All right. Thanks for playing. Thanks for playing. What number was that? That was number 4. All right, Grace. You know it's you, but I'm going to spin the spinner just so we can see the celebration. All right, Grace, pick a number. We got 11, 12, 13, 16, 19, 20.
Oh. 12.
Well, sorry, thanks. Oh, a fun one. Can you find the dog bone or the heart? Can you find the dog bone or the heart? All right, so a couple. What are you looking for, Kev? You cracking me up. Yes. All right, a lot of kids found the heart. Yes, good job. The heart is down here on the brown dog. And Kevin found the bone. Does anybody find that green bone? That's a tough one. I'm not gonna lie, it took me a little while to find it. Yes. Yes, Tiana, if you want to call it hair, okay. Yeah. That was funny. Oh, that was funny. That was funny. All right, Grace, I'm guessing that you didn't find the dog bone.
I think I did.
You think you found it?
Yeah,
I'll give you a hint. It's somewhere
it's-
here in this red circle. Just kidding.
It's right there.
It's somewhere in this yellow box.
I see it. It's in the dog's hair.
The dog's hair? I think it's his ears, but yeah. I said the same thing. Yes. Yes. All right. Thanks for picking number 12. That was a fun one. All right. Anybody want to pick a number? Anybody want to pick a number? 11, 13, 16, 19, 20? Anybody got a feeling? I got a feeling. Oh, unlucky number 13. All right. Kev was up first. So here we go. You can do this one. You guys got this. Let's give this a quick go. You got this. All right, got some answers coming in. Fantastic. All right, Deanna got it and Deanna got it. Oh, no, you're not, Kev. Don't say things like that to me. That makes me nervous. Don't make me nervous. So you've got your function. And you know the fastest way to get rid of a little tiny square when it's the only thing on that side, right? If this 7 was here, if that was what it said, you could not square root, like you cannot do that, okay? Don't do that, kids. So you can square root both sides. That eliminates the square. So you get x plus 3, but over here you get a plus or minus sign in front of your 7. Okay, so already we are eliminating some choices, right? And then when I subtract 3 from both sides, be careful here. When I subtract 3 from both sides, I get a -3 plus or minus the square root of 7. See, tricky, tricky, you got to be careful. Number 3 was the right answer. Number 3 was the right answer because we square root both sides. And every time you square root something, you get a plus or minus sign. All right. Thanks, Kevin, for choice number 13. Thank you. Thank you. All right. Let's see. Carolina, Indiana, do you guys want to pick a number? Peyton, do you guys want to pick a number, you kids? Pick a number, whoever's first. All right, Indiana's first. And she picked 20. So here we go. Ooh. A toy rocket is launched from the ground straight upward. The height of the rocket, blah, 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 is given by this equation, blah, blah, blah. T is seconds, blah, blah, blah. Okay. Here's the actual question. Determine the domain. The domain is your x values. In this case, there are no x's, right? There's only the letter t. So t is our x. So the question is, if t is time in seconds, if t is time, then the domain is talking about time. So I want you to start thinking about what types of numbers we use when we're talking about time, right? Your answers for this question have to be some group of numbers. So there are all real numbers, right? There are rational numbers. There are negative rational numbers. There are positive rational numbers. There are integers. There are whole numbers, right? So these are your options for types of answers. So I want you to think about, if you're talking about time, what type of numbers can you have? Oops, I didn't mean to do that. What type of numbers can you have? So hopefully the main idea coming across to you right now is, okay, time can never be negative. So integers is out because integers have negative values. All real numbers is out because all real numbers has negative values. Now we can have positive rational numbers or we can have just whole numbers. right? So we've narrowed down our choices here. So you can have all positive rational numbers or just the whole numbers. You have to start thinking about, can time be rational? Rational means you are part of a number. So can you have 1 second? Can you have 1.5 seconds? Can you have 1.75 seconds? And the answer to that is yes, you can have a partial unit of time. You don't have to live in just 1 second, 2 seconds, 3 seconds, 4 seconds. So the answer for this is positive, rational numbers. And because it says explain, you would say because time cannot be negative, but it can be a partial unit. And if you want to give an example like, but it can be 1.5 seconds, that's okay as well, right? You don't have to use that fancy language. It can be a partial unit. You literally could just say it can be a decimal value. You can be as simple as that, but you have to be explaining that it cannot be negative and it can be partial. Cannot be negative, but it can be partial. All right, thanks for picking that question for us, Indiana. Christian, because you had to wait so long both times, can you throw a number out for us? 16, 11, or 19? 16, 11, or 19? He's picking 11. All right, guys, we're almost done. Here's another vocab question for you. For which value, if you add P and W together, for which one would you get a rational number, right? A rational number is a number that can be written as a ratio, a number that can be written as a fraction without a square root sign in it, a number that can be written as a fraction without a square root sign in it. So start thinking. Nice job, Grace. You got it first. Good job, Kevin. So we're thinking about, can I get rid of any of these square root signs, right? Can I get rid of any of these square root signs, like this one down here? I can, that's 1/5. That's rational. But this one I cannot, so this is irrational. And if I add 1/5 to something that goes on forever, it's still just going to keep going on forever. When you add irrational numbers together, they're still always irrational. So if we take a look at number 2 here, which is the square root of 4 and the square root of 9, these in fact are rational, right? They have no square root signs in the denominator, but these other values, you cannot get rid of this. Whoops, that one you can. But these other values you cannot. So the answer was 2. The answer was 2. Thank you, thank you. All right, down to our last 2. Which one should we do first, guys? 16 or 19? 16 or 19? There's only 2 left to go. What's the majority vote? Majority vote, let's see.
19.
19, I got 1 vote for 16. Deanna, break the tie. 16 or 19? She's going with 19. All right, here we go. This is it, kids. We're almost done. What is the percent of change each year? What is the percent of change each year? Careful. Careful, careful. So I want you to think about whether this is growth or decay. Is it growth or is it decay? Good, good. All right, good answer, Grace. Now, the question is, since most of you are understanding that this is the value we're looking at, that value, which we call the B value, is less than 1, that means it's decay. The question is, how much decay is happening, right? I don't have 100% of my item anymore. So I'm not decaying at 95%. I have 95%. What am I missing? So hopefully that makes sense to you, that this is how much you have left. You have 90%, 95% left. Good job, Grace. Good job, Christian. So the answer is that the percent of change is 5% each year. Explain how you arrived at your answer. You can say 1.0 minus 0.95 equals 0.05, which is 5%. You could explain it like that. You could also explain it by saying the rate of change is less than 1. Therefore, it is decay, right? And it is 5% less than 100. Okay. But yeah, some other things they could ask you about are what's the initial value, right? So the number of carbon atoms starts at 5,100. It decreases 5% every year. And so they could ask you follow-up questions. They could ask you, you know, how much carbon atoms are still in the fossil after 10 years, after 100 years, etc. All right, last question, my friends. Number 16. This is it. This is similar to a question I gave you in class. I'm still doing math. I'm on the Zoom call. Soph's upstairs. She was doing violin. All right, so let's take a look at this question. I only got a couple of stragglers, really committed students left on the call with me here. I appreciate it. So what are you thinking? Rachel wants to model it with a linear function. Mark wants to use an exponential function. I could type this all in. I'm kind of looking here like, okay, this is going up about like 60. And then this goes up about 70. And then it goes up about 90. And then it goes up 110. And then it goes up about 140. Then it goes up about 100 and more, but like, so it's going up more every time. Like it's going up more every time, not the same amount, but it is going up somewhat every time. So hopefully you guys are thinking, oh, I should put this data in my calculator, right? Let's open our calculators up here. I'm gonna go to my stat edit. I'm gonna clear out my list here. I'm gonna start typing in some data. Let's see. I've got a 1, 2, 3, 4, 5. I can't see. Oh, it goes all the way up to 10. 6, 7, 8, 9, 10. Then for my other data here, I got 220, 280, 350, 440, 550, 690, 860, 1070, 1340, 1680. Oh, I messed up. Ugh, this happens to me every time. 10, 1070, 1340, 16. Okay, I gotta make this a little bit bigger. I think that's good. All right, stat, calc, lin reg, everything's in L1, L2. All right, that's not bad. That's not a bad correlation coefficient, right? 0.964. 0.964. All right, so I'm going to go with the correlation coefficient. Well, I'm going to write down everything here because this is some good information because I don't want to have to redo it. So let's see. My linear, oh, sorry, that's a mess. Okay, my linear regression would be y equals 154.9, y equals 154.9x minus 104 with a correlation coefficient of 0.964, right? Taking down some information. And now let's look at, Mark wants to do exponential, so I go back, I stat calc, exponential reg is off the screen, it's 0, but I'll arrow down so you can see it, otherwise you can just press 0. Ooh, look at that. I know I just shrunk it up, but hopefully you're writing it down in the correct format. For exponential, it's A 178.01, 178.01 parentheses, 1.25, 1.25 raised to the x with a correlation coefficient of 0.9999, something very good. My pen is not working. Okay. But you get what I'm saying, 0.99. So which model is the better choice? Explain why you chose this model. So hopefully you knew that you needed to kind of hatch out both of these, right? You have to try a linear model. You have to try an exponential model. I kind of had a feeling it was going exponential because you see how I knew that it was increasing every time, but every time it got bigger by just a little bit more, right? So like maybe I am getting bigger by like 2%, like I'm just making that number up right now, but maybe I was getting bigger by 2%. So maybe the first time 2% was 10, the next time 2% was 15, the next time 2% was 25, you know, so it does kind of lend itself, this pattern, to something exponential. But excellent answer, Grace. Thank you for typing that to me in the chat. The answer is, you have to answer two things here. You have to answer which model is better. So you don't even have to write this on your paper. That was just me showing you what I was doing. You have to write that the exponential model is better and why you chose it. So Grace says she chose it because it has a stronger correlation coefficient, right? Its correlation is closer to 1, right? It has a stronger correlation. It is closer to 1. Well, my friends, that's it. We finished the whole board today. Before you go, does anybody have a question for me? Something you have been wondering about, you need to know the answer to? No? All right, well, if you didn't notice, I posted some things, I think kind of late last night when I finally had a moment to myself. I posted some things on the Google Classroom to help you start your review. So one is just a packet of like flashcard type information, like things you got to review, but you have an amazing notebook that you can also be using. In addition to that, I posted some actual sample questions. I haven't posted the whole answer key yet, but I did do some other things. All right, Kev, more like a fun game, right? You want to do like a fun game, huh? Yeah, maybe next time I'll put some other questions in there. But thank you for joining me today. I appreciate it. I hope you guys have an amazing weekend. I'll see you Monday.
Bye, Miss Henderson.
Bye. Have a great weekend.
Anderson.
Bye.